Okay, welcome to Mr. Mac's Review for Algebra 2. Today's the 16th all day long. I'm here with a bunch of kids that have waited to the absolute last minute to learn this stuff. But that's okay, because I designed the class that way so they can still succeed. There are about 10 billion kids here right now. Everybody say your names, except not really, because it's going to go on YouTube and this will get me fired. So we have to be completely anonymous, and we have to come up with fake names. That's a good fake name, Eli. All right, Charlotte. Ooh, wow, daring. All right, I'm Mr. Mac in the flesh, the real one. Occasionally I will turn on this camera, but I'll probably forget to do it. It's this guy. This is what I look like now. I'm bald, former students. I forgot my my green screen today, so I'm not going to use that so much. Maybe I'll use that later. I will upload this video to YouTube, and I will put it on Classroom for everybody to see so that we can watch it. I'm going to go fairly slow, but if you want me to go slower, you can pause the YouTube video. That is the magic of YouTube. Class, have we decided we want to start with Chapter 4? Awesome. All right. Do you want me to just do all of the basics, or do you want to ask for them? All right. Here we go. Okay, cool. Let's do it. I don't know if I'll be able to get through all of that today if we do all of everything but the advanced, if I'm going slow. Fam, this is x, and we're subtracting whatever 2 times y is. If you want to just watch the show, that's okay. Guys, I printed those out just in case you wanted them, but I'm going to scan this and send it to you when I'm done. So it's better to watch the show. It really is. Okay? So scan, watch, understand, ask questions. That's what's really important. Notes are useless if you don't know what they mean. I know teachers don't like when I say that, but it's so true. You have to understand your note before you write it. All right, so if I plug in -2 and 5, I get this. Is everybody cool with that? All right, awesome. See how 2 times -y was happening over here? Well, it's still happening here. This is all one term. What is -2 times -2? Positive 4. So now we can add these and get 9. How we feeling? Excellent. Should I do the next one? What about part C? I want to hear no no's. I only want to hear yeses. Yes. I will do part C. If you don't want it, don't say anything. Hello? Yeah. Yes, a lot of you guys like to distribute here. Is this multiple terms? No. So you just do 3 times 5 and then times it by -2. Or do 5 times -2 and times it by 5. Any order works, but you cannot distribute. So we'll do 3 times 5 first, which is going to come out to 15, and then times that by 2, which is -30. No matter how you do it, you should get -30. This one down here is 2 times whatever x is. X I chose to be blue. Make sure whenever you plug stuff in, you wrap it in parentheses. Then we have whatever y is squared, and we're adding whatever x is squared. The squares only apply to the y and the x. That's it. A lot of you guys like to apply it to everything. Don't do that. So we know x is 5, and we know y is -2. What does it mean to square something? Good. So I'm going to rewrite this like this. If you write it like this, you won't make mistakes. This is 5 times 5 times -2, right? We cool with that? All right. So now we just multiply. Before you do this, I highly recommend that you guys think about whether it comes out negative or positive first. So right here, is this going to be negative or positive? It's going to be positive because 2 negatives multiply to a positive. In other words, it's negated because of this, right? And we times it again, it negates it back to positive. Yeah. So this is positive 4 times 10. Are you seeing it? That's 40. This is 25 times -2. Is that going to come out negative or positive? Negative. So adding a negative is the same thing as minusing. And we get -50. What is 40 minus 50? Definitely negative. -10. The way you should think of adding and subtracting negatives is like an elevator. If I'm on floor 40 of the penthouse and I go down 50, I'm in the basement now, right? I'm -10. Adding and subtracting is moving. Multiplying and dividing is like stretching and shrinking.
Guess who's coming?
Ooh.
Riley.
Oh, yay.
No, Riley. Riley. You got your perfect name. Riley.
Riley is the nickname.
That was a close one.
Jeffrey E.
Does anybody know her social? All right, turn the page. Don't say it right now. I meant social media, not social. I meant social security number, not social media. That's funny. You guys thought social media, right? That's funny. I'm an old man. Would anybody like to see this one? What are we doing? Add them. We're adding them. By the way, if this isn't on screen, you have to tell me, okay? Because I want to save time. Did you know you can add them like this? That's 6 B's and negative 4 A's, yes? Hello. Don't say your real name. It's Riley. Okay. Riley Wazowski. All right, so now we've got this. This is another way to do it. We're adding these two, yes? See how they're like terms? We're going to get 6 B's. She's watching right now because this looks really similar to her final. Negative 7A and 3A is going to get you negative 4 B's. Are we seeing this? Or 4 A's, I mean? Right, so add them up either way. But when you add a negative to a positive, it can come out positive or negative. The reason this came out negative is because if I'm at negative 7 and I go up 3, I'm still at negative, right? I'm down 7 in the basement, and if I go up 3, I'm still in the basement. Where am I at? Minus 4, under 4, right? So there we go. You understand, you understand. All right, this one, we're adding. So you can either add them like I did, vertically, or you can just add like terms. 9Z and negative 9Z. If we add those together, you're on 9 and you're adding negative 9. So we're at 0, right? 0Z. I do not want to see you write Z if you meant 0Z. What does Z mean? 1Z, right? So 0Z is just nothing. Just don't write it. Will these always go away? No. Sometimes I just feel fun. Negative 2Y plus 2Y is also nothing, okay? Like that one dodgeball team last year, nuttin' for Christmas. Nuttin' for, thank you. 6X and 3X is how many X's? For some of you, that's a lot of X's. For the others, not so much. Live in Texas. All right. So that's just 9X. All right. Let's multiply all these. So it doesn't matter what order you multiply in. What is Y times Y? Y squared. 2Y means Y plus Y, right? Double Y. We're not doubling Y. We're timesing it by itself. So what is Z times Z times Z times Z? Good. And you don't have to do it alphabetically, but I'll put the X out front. This is X squared, right? And they're all being multiplied still, but that's as simple as you can get it.
Wait, we don't put plus?
No. Where does it say add? It's timesing, isn't it? See how they're next to each other? They're still timesing. They're just more condensed now. Okay? Are we okay? Okay, that was a look of concern. I wanted to make sure. She's just doing that stare. Part B. The reason people get confused is because this is not 0 A's, it's 2 A's, right? So how many A's are being multiplied? A to the 5th, and it will be B to the 7th. This is true. Okay. Cool. Remember, you don't get notes on the final, so it's very important that you study ahead of time and make sure you actually understand this. If you understand it, there will be a lot less to memorize. Wow, don't be saying that on the thing. Fake name, Eli. We're expanding. That means we're going to distribute. 35R minus 20 S's. Are we seeing if we distribute that, we times? Here, everybody gets freaked out because we're not used to multiplying from behind. But guys, multiplying from behind is the same as multiplying from the front. You just got to be careful when you do it. Here we go. We do this. This, and this. Is 3x times x 3x? What is it? 3x squared. What's 3x times y then? And this will be negative, right? Negative what? Very good. Riley Wazowski. Because it's going to go on the internet. I'm recording. All right, here's the one that really kicks everybody's butts. You know why? Because we're minusing, and you guys are bad at minusing. So check this out. I'm on 1x, and I'm taking away 5x's. Negative 4x's. I'm on 1. I'm going down 5. I'm at negative 4x's. Cool. All right. If I'm on 7y and I take away negative 4, fam, what is minusing a negative 4 really doing? It's adding. You know what adding or what regular minusing is, right? Minusing 4 sends you down. So minusing negative 4 must send you up. So if I'm on 7y, I'm really going up 4 to where? 11y. Don't lose your variables. Don't lose your x's. Stock them on Instagram. You could write it like this. You could write this as x plus 7y and distribute the negative. Are you following me? You can distribute the negative if you want. But this is not distribution because we're not timesing. Just because it's parentheses doesn't mean you distribute. And division technically distributes, but yes. Good question, Riley. All right, this is factoring. This is the opposite of distributing. It is not dividing. Do they have a common factor? Yes, it's 6. Or negative 6. I'll do 6. Do you see how I didn't divide by 6? Dividing by 6 would be this. That is not okay because this is not an equation. If you divide by 6, it changes the problem. But if you factor, do you see how it would go back to the same thing? Right? That's super important. You can't just leave off the 6. How many copies of negative 6x plus 5y must be added together to get this? 4 copies. Are you seeing that? 4 negative 6's, right? And 4 5y's. Poor Lord is expanding his brain right now. I can feel it. Giga brain. All right, negative 5 over y plus 3 over x. Can we Samantha with the 2 head over there. All right. Yeah, that's all right. Fam, Samantha with your forehead that is 2 fingers wide. With whatever brain cells you have in there, and Samantha's a made-up name. Can you give us the reason why we can't add these together?
Because there's no common denominator.
Stop. I asked her.
Multiply by n, you gotta multiply by xy.
So, close. If I multiply by y over y, everybody, what is y over y? 1. That won't change anything because I'm timesing by 1, right? That's important because this is not an equation. It's an expression. No equal sign. Now, this right here, you remember the days, right? If I times by x over x, that won't change anything. However, now, they're going to be the same denominators. Do you see how this will be xy on the bottom? And this will also be xy on the bottom? That's why I did it. What is negative 5 times x? And this is 3y. So now I can put them together all over the same thing because division distributes, just like multiplication does. So Briley, check this out. Do you see how I'm dividing by xy to both of them? It distributed if you do it in reverse. Yeah. There was another student. I was talking to Lexi. I called her Briley so no one would know her real name. That's how I'm covering. Big brain. Big brain. They said I was saying Briley's name, but that would be illegal because that's her real name. I was not talking to Briley when I said Briley. I was talking to Lexi when I said Briley, so now it's fine. That way it wouldn't sound like your real name. Now no one knows your real name.
All right. What's your address, Mr. Matt?
Yeah. Ask Thomas Schlaffer. Although he doesn't know it anymore. Well, he probably does. All right, fam. What does it mean to get x in terms of a, b, and c? Raise your hand. Raise your hand. Raise your hand. Yes.
You get x on its own.
X equals a, b, and c, right?
Yep.
Stuff with a, b, and c in it. So everything that isn't x must go. Reese, are you okay? You promise? Okay. If we're trying to get x on its own, that means everything that's not x on this side gotta go.
Multiply by a.
You can multiply everything by a. That's legal. You can also add b first, right?
Yeah, that's fine.
Yeah, I mean, it's up to you. It doesn't matter. I'm going to add b first because I think most people freak out when we multiply by a first, but I don't care. I multiply by a first all the time. Do you see how if I add b to both sides, it goes away here and becomes over there? Right? All right, now we're going to multiply by a, and that's going to get rid of this, right? If we times by a, those divide out. That's why I did it. Because you definitely could, or you could times them individually. I don't care if you write ac plus ab, or if you write a times c plus b, but it has to be in parentheses if you're going to do that, okay? So either of these work. Because A does go to BOFA. And again, I apologize for the soundboard not working. If I was healthy, I would have fixed this weekend. My bad. I can still do this, though. I can still do this. But the sound, no sound. I don't have a BOFA button, but that'd be funny. That'd be very funny. All right, now we're taking the same thing and getting B on its own, right? There's a much easier way than doing that, and no, you would not, because that'd be x squared over a squared. That wouldn't help anything. Here's what I'm going to do. Big brain play. I'm going to add B over so it's positive. Why do I want that? Because I want positive B, right? And then I'll subtract C and I win. I know. None of this is actually that hard. But if you don't learn it during the school year, then yeah, it is because you haven't learned it yet. Yeah, but now you're not really learning, but you're doing something close to it. Yeah, I'm trying. All right. Fam, any other questions? Are we on them? Yeah. Would you guys like to do the intermediates? No. I'm hearing yes. Okay.
I'm only a basic type of guy, though.
Well, then you're good, right? You can relax while we do this.
But maybe I could upgrade my game.
You really could. They're not that hard.
But I'm just limiting myself.
Yes. Do you guys see that whenever I plug stuff in, I wrap it in parentheses? Okay. You have to do that. For those of you that use calculators, I know who you are. If you plug in -2 squared like this to your calculator, it'll give you the wrong answer. It will give you the wrong answer because this means I want the negative version of 2 squared, which is -4. Here's why that makes sense. What does this mean? What does this mean? -2. This is the negative version of 2, right? So we need a way to be able to write the negative version of 2 squared. That's how you write it. This is not the negative version of 2 squared. It means take -2 and times it by itself. What is that? +4. There's a difference. There really is. And then this becomes 8. 4 over 8 works for me. However, what common factor do 4 and 8 share?
2, 4.
How about 4? That's a little bit better. Because then these divide out, and I get 1/2. All right. Would we like to do this next one? -2 to the 5th. What is it? It will. What does it mean to take something to the 5th power?
It means to multiply myself 5 times.
So it will come out negative because we have an odd number of negatives, right?
Can we just write that?
You can think, no, this is negative, now it's positive, now it's negative, now it's positive, now it's negative. She loves me not. What is 2 times itself 5 times? Let's do it together. 2, 4, 8.
16.
So it's -32. All right, this next one. You have options. You can distribute first. Some of you guys might prefer that. I'm going to do it the low-tech way.
Are those conjugates?
They are. You know conjugates multiply to difference of squares, right? So that could be much easier to distribute first and then plug in your numbers. So it's up to you. So it says x is 5, and it said at the top that y is -2. Are you guys following me? Don't be afraid of using parentheses inside parentheses. Just make the other parentheses big, right? The big ones, the outside ones. This is going to get us whatever this is times whatever that is. This is -6 minus 5, which is -11. Because we're doing the intermediates, I'm going to go a little bit faster. Okay? I'm assuming you guys know that stuff. This is -6 plus 5, which is -1. So when I multiply these, I get positive 11. What if we had distributed first? Well, we'd have gotten 9y squared, and we've got a -x squared because the middles would have gone away, right? And so you could have plugged it in like this. Looks like 4 times 9 is 36. 36 minus 25 is 11. Up to you. 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 If you don't like lots of parentheses, this is the better way to do it, right? Oh, that's funny. I love stuff like that. That's dumb stuff. I live for dumb stuff. That's not stupid. It's dumb. I love dumb stuff. All right, check this out. A times C. Are you guys following me that that's A times C? This is really easy. I'm going to show you how, okay? Did you see how I plugged in a times c in parentheses? Are you seeing it?
Yeah.
Then I'm going to add whatever a times b is. That's 2/3 times -1. Then I'm going to add on whatever b times c is. Here's b, here's c. All right, fam. These are separate terms. We can't add them together yet, but we can multiply or divide in any order. Do you see how it says 9 times 2? And it says 9 divided by 3? You can do either or first. Let's do 9 divided by 3. What's 9 divided by 3?
3.
And then what's 3 times 2?
6.
Isn't 2/3 of 9 6? That makes sense. This has come out to -2/3. And this is going to come out to -9. What do we need, Samantha? What do we need? Kami denomies. Let's times by 3/3. We get 18/3. Thank you. Good job, Harper. Why did I put minus? Because this is negative. So adding a negative is minusing. So we do this, we get -27/3, right? Cool. So how many thirds are we going to get in total? Well, this is -29, right? If we add a positive 18 to it, we get -11/3. Not so bad, right? That's the worst case scenario, too. It's the worst version of this problem.
So assuming they would write that down.
Well, what I'm saying is if you can do this, then you can do anything.
I got you, dude.
What does it mean to square something?
Times by 2.
So that what's -1 times itself? So we have 1 times 2/3 times 9. Well, that's just 2/3 times 9, right? It'll be 6 again. We just did this. Right? 3's divide out, and we get 3 times 2. That's it. It's just 6. Then you can go, just not in here. Okay. Mhm. All right, so we want to do these guys or no?
I feel like you need to do all of it. But maybe that might just do one of them or the other one.
You see that, and that is why you succeed. Does that make sense? You see the bigger picture. Do you see how 2c² and 7c² were already good to go? Are we ever going to be able to add that to these two? No, because they're d²s, right? So what we really need are common denominators here. So this is thirds, right? So how do we make this common denominators? Nope. Nope. Multiply by 3/3. What is 3/3? So it won't change the number. Dividing or timesing by 3 will change it. And so what, yeah, that's also true, but this is fine. What is timesing by 3/3? Does timesing by 1 change anything? Doesn't do anything. We're good. It just changes our perspective. What's the question, Samantha? Because these guys are never going to combine with this. It's separate terms. That's c². It's never going to combine with these. Because those are d's. Okay? So all we're trying to do is get these combined. Okay, yeah, I knew you were going to say that. All right. So timesing by 3/3 you can do any time you want because it's just timesing by 1. So you can get away with it if it's not an equation. That's when we want to use it, right? So these get them to have the same denominator. So what is 1d²? That's what that means. 1d² minus 12d². Either write it on the side or you can write it up top. It doesn't matter. Lord, you're leaving? I'm sorry. Goodbye. Yeah, not you. Not you. No. No, I'm pointing at Samantha. Poor Lord's waiting to get the stuff that he needs to actually see, and he's like, well, I'm out of here. I don't blame you.
Are you doing 4, 5, 10, and 11?
I'm doing as many as I can. We'll go as fast as we need to go. I know. All right. Are we going to skip D or no?
Just do one of each section.
Okay.
Yeah.
Which one, A or B?
B.
Okay. Doesn't matter what order you multiply in. So let's multiply 2, 3, 4, and 2. That's 48 if you multiply all those together. And then r squared times r is r cubed. That'll be r to the 6th. And it'll be s to the 6 and 3, so that's going to be 9 s's being multiplied all together. It doesn't matter what order you multiply things in, so that's why that works. How are we feeling?
Can you multiply the R separately? This 4RS.
Say it again. This just means 2 times r times 3 times s times s times s times s times s times 4 times r times s. It doesn't matter what order you're doing them. Parentheses do not mean do them first. All right, which one? A or B? B, right? What does it mean to cube something? So we're going to times everything in here by itself 3 times. What's z cubed times z cubed times z cubed? What's v to the 4th times v to the 4th times v to the 4th? What's negative 2 times negative 2 times negative 2? 8. 2, 4, 8. And it will be negative.
That's what always messes me up because
I know.
I like don't I just like multiply
Yep.
A. Would you multiply the 4 and the 3 or are you adding?
Well, what I'm thinking is this means,
Not that one. Another one. A.
oh, part A. Oh, I'm sorry.
Are you multiplying or are you adding?
Well, we're multiplying, and here's why. This means times it by itself 4 times. So if I have x cubed times itself 4 times, how many x's are being multiplied? 12. And if I have y to the 4th times itself 4 times, how many y's are being multiplied? 16. So altogether it's x to the 12th times y to the 16th. Yes. All right. 424. Okay. I'm going to write out the whole thing so you can see it better. A lot of things divide out. Yes. Whoever that is.
Don't say that. My name's Jeffrey.
And he's white. Well, Jeffrey. Oh, wait. Sorry, that guy that graduated last year. All right, anyway, we're not going to say his name. It's in the internet. Yeah, all right, fam. We're going to divide them all out. So check this out. Hey, isn't 9 3 times 3?
Yeah.
So one of the negative 3's will divide out, and we'll be left with 1 3 on the bottom and 1 on top. Are we seeing that? Negative 3 over negative 9 becomes 1/3. How many x's are left? None. They'll divide out. How many y's are left?
2
On the top, location, location, location. How many z's are left? 3 on the bottom. If you don't want to write the 1 there because it annoys you, you can write this. Right, same thing. Keep the 1 or don't. I don't care. 1 times y squared is y squared. Alrighty. Next. Yes. That's okay. That's a great question. That's a great question. So if you imagine y to the 7th means this. It's got a bunch of y's, right? 1, 2, 3, 4, 5, 6, 7. And the bottom is y to the 5th, right? All of the y's divide out on the bottom, except for 2 on the top, so it's y squared over 1, right? Or just y squared. Oh, I mean, you kind of do, right? There you go. Doing okay, Lyric? I mean, whoever you are. Dan. That'll really keep him in the dark. All right. All right, what do we times this by to get this?
8.
Definitely 8. That'll get us 24. What else? X to the 4th. That'll get us x to the 5th. And t squared. All right, can I give you a crazy one? What if this is what I started with, and this is what I wanted to end up with? Oops, t to the 5th.
It's just t to the negative. No, I think.
Are you guys following me? Okay, good. So you know either way. Ugh.
Why do we have an advanced on our final?
Why?
I never even looked.
Because some people want to get it and they need evidence for it.
Okay, but if I don't do that, that's against me.
It just means you've never got it, so your grade will be the same.
Fill it out and able to do something.
If you've never done it yet, you can only lose stuff you've already gained. Yeah. And if I don't remember.
I think you did, but I don't think. Well, then that's gonna.
All right, fam, this next one, I want you to change this because I want to show you something neat. Okay? If you leave it as is this the same as that? Are these the same? No, it's a minus and a plus there. It doesn't work. You would have to distribute the 3, you'd have to distribute the 5, and then subtract them all, right? But I want to show you what happens if it is the same. Check it out. You can, but let me show you something. We have 3 of them, and we're taking away 5 of them. So don't I have -2 of them? Now we distribute. A little bit faster, right?
But it's not like that.
If it's not like that, then you have to distribute first and collect like terms. I'm not worried about it. I'm not worried about it. I want to show you what it is when they're the same. Okay?
That's how it is on the final.
Maybe, maybe not.
I'm gonna go with yes because you keep trying.
If you don't know that, if it's not the same, you just distribute the 3 to everything, distribute the 5 to everything, and subtract them. Right? Like, it's nothing special.
I've been highlighting the ones I need to remember with the clues.
Good. I'm glad we know how to study now. All right, friends. What common factor do these 2 terms share? They share a 4, an x, and a y. So whatever's left over is going to go here. What do we multiply by 4 to get back to 16? 4. And we also need an x squared to get back to x cubed. And we already have the y. What do we multiply 4xy by to get -4xy? You got to have that -1 there. You have to. Otherwise, it wouldn't distribute back to this.
Okay, next section.
Do we want to see this one? But no, I don't want NARS. I just want YARS. Does anybody want to see this?
Can we do D?
D is fine. What common factor do all 3 have?
3.
3 is the biggest one. You could also do -3, but we'll just do 3. What do they have for A's?
1A.
1A.
Oh crap.
Do they all have a B?
No.
They do not. Do they all have a C?
Yeah.
Most we can take out is this. So we're left with -6a cubed, c to the 4th, plus 3a c to the 4th, -1. Are you getting that -1 again?
Yes.
Okay.
How is factoring gonna help you in life? I don't see how you do that.
Algebra 2 is factoring the class. Factoring makes everything easier. Yes, ma'am.
Okay, then
Thank you. You're right. There was a B here. You're right. There's a B. Good job. -B. Thank you. Remember, this class is not meant to train you for a job. That's what your employer's supposed to do. This class is what all school is really for. It's to make you a better thinker. And if your classes aren't making you a better thinker, then they are a waste of time. I agree. But this is going to make you a better thinker. Samantha, let's think. What do we need? How are we going to get them? By what? We need 10x squared. Nope, there's a quicker way. There's a quicker way. If we multiply by 2x over 2x, won't that get this to match? This is a lot quicker. Could you have done both sides? Sure, but it's a lot messier. Because what is 2x over 2x? And do you have to times everything by 1? No, it didn't change anything, right? That's the beauty of it. And so now when we distribute the 2x, we're going to get negative here. Well, we'll talk about it in a second. -14x and -2xy. Are you guys seeing that? I know, because we're going to have to talk about it. That negative applies to everything. So check this out. It's not wrong. Here's the final answer. 3y minus 14x plus 2xy. Why is it plus 2xy? This minus is applying to all of it. Minusing 14x, minusing negative 2xy. Are you seeing it?
How is that going to?
Well, this says minus all of this, right?
So then wouldn't it be 3y minus?
You're seeing it?
Why is it 3?
So, fun fact, the original problem actually could have been this.
So then why would it be 3y minus 2?
What they did is they basically combined these two, right, to this. And it was supposed to be minusing everything. That's what was happening there. So, yeah. Just watch out for the double negative. What was your question? You sure? Okay. Are we ready for 451 and to be done with the intermediates?
Yeah.
Okay. Why is this one intermediate? All the others were basic. What's weird about this one? We did one. We did this one earlier. It's just A is on the bottom. That's what makes it weird. So what if we just get A out of the bottom first? Then it'll be easy, right? Times everything by A, every term. A's divide out, we get 1. 1x minus AB equals AC. We want to get A on its own, so all the A's should go to the same side. How did I get there? How did I get there? Lyric, did I goof? What? Oh, okay. How did I get from here to here? AB to both sides. Thank you. Now, here's the trick. Here's the thing that catches everybody. How do we get A on its own here? It's not going to be adding, subtracting, multiplying, or dividing. Eventually, you're going to have to think it's factoring. If all the A's are one side, we can factor from when? Oh, you want to take them?
Yeah.
I don't have it scanned, or I do have it scanned. I don't know. Here's 4. Right now. Why can't you finish it tomorrow? Mumford, come here. Yeah, no problem. What? I think that would be a good idea, but we're going to do it in quiz order. You, right here. They want to go through every single one.
I gotta go grab a pencil.
Cam, that's why her Lord left, because he didn't want to do every single one in order. So that's what they want to do. That's what we're going to do.
Can I steal a pencil?
Yeah. We're not done yet. Is A on its own? Yeah. Unless somebody wants them, yes. Are you following me? Divide by C plus B to both sides? This is times by C plus B, so we would divide by C plus B. A equals X minus B over C. Why would you divide by C? No, you'd get one A on its own, but not both of them. You got to get A on one side with nothing else. No, not when they're together.
This, and then you divide by C.
All right, here's something you need to stop doing. Stop doing multiple steps all at once when you're doing this work. It gets you guys lost. If we times by A, then we get this. You forgot to times everything by A, Samantha.
I did.
Yeah, you didn't. And then that changes things, right? All right, now, stop. Would anybody like, did I give you mine? Give it back, Samantha. Would anybody like to see quiz 4 advanced problems? Okay, Samantha, you can keep, actually no, because I need to scan it, so bring it back up, Samantha. All right, quiz 5, are we ready to go? We didn't. I will take requests. Does anybody want to see any of the basic quiz 5 stuff? Okay, I didn't ask that.
No, I just want to skip to intermediate.
Okay. So we will skip to intermediate.
We got
You do or I do? They do. All right. What do you notice about these two equations? They are. If you times it by 5, they're the same. That means anything that works for 1. Yes, so it wants you to find 3 of those infinite solutions, right? So we're going to do that. Anything that works for the top will work for the bottom. Can anybody give me a number for x? Give me a number for x. 5's a good one. What's 3 times 5? 15 minus 14 gets you 1. How do I make this 14? 2. You could do that if you wanted to. Can somebody give me another number for x?
Why can't we do 5 and 5 and then they would be the same except for
Because if you plug in a 5 here, you get 15, and you plug in a 5 there, you get 35. Is 15 minus 35 1? Simplify in what way? Yeah, perhaps. You can use, yeah, you can. So, Lyric, do you have a suggestion for x? Or are you just thinking? 12 and 5? Yeah, that'll definitely work. Lyric sees 12 and 5 will work, because 12 is 36. 36 minus what gets you 1? 35. How do I make that 35? 5. Now, do you need to find nice numbers? Because Lyric went for a while before she found any nice ones. Let's just plug in a random number like... you can use delta y and delta x. Do you see how we have a plus 7 here? And we have a plus 3? Hey, look familiar? Delta y, delta x. Delta x, delta y. Now, what if we weren't going to do nice points? You should feel okay with this. If x is 1, what does this become? Hello? If this is 3. 3 minus what is 1? Try again. 3 minus 2 is 1. How do I make that 2? Here's why. Here's why we know 2/7 works. This is 3 minus something equals 1, right? So it's got to be 2. What times 7 gets you 2? 2/7, because the 7s divide out, yes? So that's why that works. If you don't fear fractions, you can find answers really quick. You just pick a number and see what goes with it. All right. Why can't we not find a number that works for the top but doesn't work for the bottom equation? Because they're the same. Moving on. How can you quickly find more answers that work here? They say this is one of the answers. How can we quickly find more answers that work for this? Delta y, delta x. What is our delta y? What's our delta y here? Plus 2. And what's our delta x? So that's how you can quickly find more answers, right? Use your words. We cool with that? I know. I was there. All right. Do we want to see these two?
Yeah, I want to see both.
All right.
These ones, you don't make times that with this one.
The key is to simplify as much as possible without making mistakes. That's the key.
You said that like it's confidence is really key, which is
Confidence is earned. We talked about this. What can I do to make this easier to work with? How am I going to simplify it? What makes this complicated? Let's multiply to get rid of them. Can we do that? It's an equation, right? What number can I multiply by that'll divide out with 6, 2, and 3? 6. 3 doesn't divide by 6. 18 would work too, but like why use 18 when you could just use 6, right? Now, you got to be careful. You guys like to just say things cancel. Don't do that. It's going to screw you up here. What is 6 divided by 6? 1. So now we got to do 5s times 1. What's that? Good. That's why we did it. I got rid of the denominator. Here, the 6 does not cancel. What's 6 divided by 2? So we get negative 33. Are you guys seeing that? Here, the 6 doesn't cancel. What's 6 divided by 3? It's 2. So we get negative 4r. Doesn't that look easier to work with? What do you think, Christina? Does that look good to you? What can we times the bottom equation by? That's going to get rid of all those denominators. 9 is the smallest number that'll work, right? Because 9 is divisible by 3. 9 is divisible by itself, right? So 9 divides by 3 to get you 3. What is 3 times 2r? 9 divides by 9 to get you 1, so that just becomes 28. 9 divides by 9 to get you 1, that just becomes 8s. Now before we get going any further, what do you notice about the blue equation? That's true, we could shuffle it around a little bit, but what do we notice about the blue equation? We can simplify it. Let's do that. The blue equation, if we divide everything by 2, is going to be easier to work with. 3r plus 14 equals 4s. And that's going to make your life a lot easier. Oh boy. These kids don't know how to write their 3's, and I'm supposed to teach them algebra too.
I remember doing this stuff and it was just like,
Well, that's why we're here. If this is review for you, this is going to work really well. If this is your first time learning it, it's going to be kind of rough, but it's better than nothing. Okay. All right, so now we're going to take these equations and we're going to use substitution or elimination. If you wanted to do elimination, we'd have to move everything around and we'd have to multiply to get them to work, right? It's going to be too much. Stop trying to fix them, okay? You can't fix them. Stop. So instead, how about I take the blue equation and get s on its own? If I get s on its own here, what do I have to do? Divide by? They follow you if I'm getting s on its own in the blue equation. Divide by 4. So s is 3r plus 14 all over 4. Are we cool with that? All right. Why did we do that? Because now we can substitute it into the other equation. 5 times whatever s is minus 33 equals negative 4r. That's our red equation from earlier. And yeah, that's kind of poopy. That's true. I'm glad you think that way. Good job. But there was no way around it, right? So like Hadley was saying, we would love that 5 and 4 divide out, but do they? 5 and 4 don't divide out. That sucks. Can we divide all of this by 4? And 14 is not divisible by 4 either. So we're going to have to multiply to get rid of that 4, right? Reese, do you need goggles? Fours divide out, that's why I did it. And we're going to end up with, oh, my purple pen, where'd you go? Purple shows up so well on here. That makes me sad. That makes me sad. That's all right, you can have it. All right, I'll use pink. This is 5 times whatever 3 plus 14 is, 3r plus 14 is. Now, fam, here's how you multiply big numbers in your head. What's 4 times 30? 120. What's 4 times 3? So 132. You were adding or something. So now, when we distribute the 5, I'd love to divide everything by 5, but are they? No. Yep, stop doing that. What's 5 times 14? Better question. What's 5 times 10? 50 and 20. What a nerd. If we get all our r's together, we're going to get 31 r's. How do you know Purple Rain equals 62?
How do I know Purple Rain?
Oh, you know Purple Rain.
From my papa, because I am all.
Because I am all.
Hey, you just squirted on me.
Stop.
We gotta do the system back. I gotta go. Divide by 31. I need R, bro. Divide by 31.
Do we see how this becomes negative 62, and when I move them all over, I get this?
Whoa.
You've been trying for so long. R is what? 2 times 31 is 62. If R is 2, we can plug it in here and get S. S is going to be 20 over 4, which is 5. Camden, you hanging in there?
So I got 11.4.4, but I don't understand the one with 11 point. You know what I'm talking about?
Yes, you have to rationalize the denominator, right?
Yeah, but I don't know how to do the first one because it's got weird roots.
Yeah, I know.
Is it the cube roots, you mean?
It's huge numbers.
It's because you need to multiply it in a way that gets rid of the cube roots, so you need to do a difference of cubes. It's on the homework, that's why it's on there.
How do you cube?
Yo, why can't I close my
You need to multiply it by a binomial. You know the cubes formula?
Yeah.
It's that, but you have to figure out what A and B are. Good luck.
I can't close my
And it's written in reverse because the minus comes last. You need to flip the last two.
Martha, out of here.
Bye.
You think you can show that on the board?
At some point.
Where's the camera pointing?
Right now it's there.
Charlotte, out.
Do we want to see this last one? Okay.
No.
I'm hearing yes.
Who says yes?
If we times everything by 10, we get this. If I rearrange this equation, I'm going to get 22x's. I'm going to get negative 29y. Nope, negative 31y's equals negative 32. So there's my equation 1. Okay, right here. Equation 2. If I times everything by 10, I'm going to get 10x equals 6x minus 10y plus 88. And if I rearrange that to get it in standard form, I'm going to get 4x's plus 10y equals 88. What do you notice? Add 10y minus 6. This is the blue equation. We can divide everything by 2. This is the black equation. If I never divide everything by 2, I get this. You can do that with equations. And so this is going to be my equation 2 after I simplify. Cool? Those are our two equations. I think we'll do elimination on this one just so it's faster. I wouldn't recommend it necessarily, but like it'll work. So check this out. If I have 22x's minus 31y equals negative 32, I'll do it in this color now. And I times all of this by 11. This will be 22 now, won't it? So I'm going to times everything by 11. It will. Like I said, I wouldn't recommend this, but it will be faster. 44 times 10, what's that? What's 44 times 10, Briley? Try it again. 44 times 10. Wait, did you say 440? I heard 140, my bad. 440, and then if we times on another 44, right, we're going to get 484. Yeah. You did 10 times 440, right? Did you say 140?
Yeah.
Oh, well.
I thought you were breaking it.
Yeah, 44 times 10 is 440. Times 1 is 44. Add them up, you get 484. How would I eliminate these? Subtraction, yep. This becomes negative 86y equals negative 516. If you had to guess, what times negative 86 gets you negative 516? Give me a guess. 2's a bad guess because that's going to get you 160 something, right? 7's not bad. You get 7 times 80 is 560, but that's going to be too much. It's 6. Here's how I know. 6 times 6 will always end in a 6. That's a good guess. And I knew 7 was too big from your guess. So that's 480, and that's 36. 480 and 36 makes 516. So y is 6. If y is 6, we got to plug it in somewhere and get x. So let's plug it in here. Y is 6. So that means we know this. Isn't this 30? What do you add to 30 to get 44? So we know 2x equals 14, right? That means x has to be 7.
Sorry, algebra. The network's gonna be off after school, so we might get kicked off.
Why?
Because they're like doing something stupid.
Why would they do that during finals?
They're doing it after school hours.
That doesn't matter. What is wrong with people? Oh my God. We have all of winter break to do crap like that. Oh my God. I won't have internet to be able to upload videos and stuff or make more. Wait, hold on. I have a way around it. It's okay. We just won't be able to live stream. I have a way around it. I'll just transfer them to my home computer. It'll be fine. I'm gonna need like a gigantic disk drive though or something. 'Cause these files are gonna be huge. Or a flash drive in it. All right, cool. Do we want to see this one? Yes or no?
No.
I need to follow you on YouTube. I already follow you.
Anyone want to see these? They're just like last one. Multiply to get rid of crap.
No.
Anybody want to see these? No more intermediates? Eric and Bob, is that a yes?
You do Eric and Bob, and then the 3 equations.
I can do Eric and Bob, yes. All right. The sum of Eric and Bob's weights, that's this. Are we on the same page? This is page 11. Geese. E plus B is the sum of Eric and Bob's weights. You wanted to see this one, right? Okay. What? Meese. That's funny. Eric and Bob's weight is E plus B. 9 times the difference of their weights. Now, here's the catch. If you add 2 weights together, will it be negative? So what if I minus weights? Could it be negative? I don't want that, because then it wouldn't be equal. So I'm not going to do E minus B, because Eric weighs less than Bob. I'm going to do Bob minus Eric. Otherwise, it won't work. Are you catching on to that? Because that's super important. You have to do Bob minus Eric. Because Eric weighs less than Bob. The positive difference of their weights, that's this. Positive difference, it comes out positive when you subtract them, is 240 pounds less than the sum. So here's the sum. Which weighs more, the sum or the difference? The sum, and that makes sense, right? How much more is it? Yeah, it's 240 more. So this one's more. So are they equal? No. How do I make them equal?
240 on the left. Subtract
Subtract 240 or add 240, right? Add 240 to this side. I'd probably subtract 240 from this side. You want to see something crazy? That bottom equation we can simplify. You should always simplify before you start.
E minus C goes to left.
Yeah, it does. That's crazy, huh?
But then you also 240, so it's the minus.
Check it out. We know Eric's weight now, don't we? Yeah, the E's didn't go away, did they? No, they did not. Eric is 120, which means now this top equation is easier to work with. It's 120 plus B equals 9 times B minus 9 times E after I distribute. I'm going to combine my variables by subtracting B.
Put 120 in.
Oh, thank you. And check this out. I'm going to add this over. I have 9 120s that I'm adding over, and I have 1 120. So isn't that 10 120s? Pretty sick, right? 9 of them added over. Now I have 10 of them. So this is 1,200, right? What do you times by 8 to get 1,200? I bet you don't know. So let's divide both by 2. You're going to get 600 equals 4B. Maybe you don't know that. Let's divide both by 2. You're going to get 300 equals 2B. 150, yep. Bob is 150 pounds. Yeah, for real. Yeah. But we found Eric, and it made it easier to find Bob, so such is life. Balls. Do we want to talk about the green balls and red balls?
Let's not. Yes.
Yes, okay. Check this out. It wants this. 8 red and 8 green, right? Together. So this is what we're looking for. Yes? Okay, there's going to be a really slick way to get this. This is like Tweedledee Tweedledum. 5 green balls, 2 red balls, each weigh 4 pounds together, right? 1 green ball plus 4 red balls is 2 pounds. I'm going to add these up without eliminating. Do you see why? You could. But because I don't actually want to eliminate one of the variables for this question, I need to check first, is there a more clever way to do it? And there is. I'm going to add these and nothing's going to go away, but that's going to be a good move. Do you know why? I'm going to get 6G equals 6R. And that's what's important, because if I divide all by 6, I get my answer, right? I get a G and an R. This means that this is true. Right? No, 1 could be 1/4 and 3/4. It could be 1/3 and 2/3. You don't know. But we don't care, do we? Because if we know if they add up to 1, then 8 of them is going to add up to 8. Right? Together they're 1. So if I have 8 of them, they're going to add up to 8. That's clever, huh? Don't need to find G and R. Could you have found G and R? Yes. But you don't have to for this one. We good? That's the answer. We found them together. 8 balls of red and green. Yeah. Do we want to do the area of a square and the Janus problem? All right, check this out. I'm going to show you the easiest way to do this. This is not how I thought of it when I first attempted it, though. So it says at a certain time, Janice, notices that her digital watch reads A minutes after 2 o'clock. So here's A minutes after 2 o'clock. Fam, if it is 15 minutes after 2 o'clock, it's 2:15, right? So A is 15, it's 2:15, yes? What if it was 16 minutes after? A would be 16, good. So it says 15 minutes later. Okay, well that's going to be 15 minutes later, right? Yeah. Right, if it was 15 minutes after, now it's 30 minutes after. If it was 16, now it's 31, right? Cool. It is now equal to B minutes after 3 o'clock. So that's B minutes after 3. Now hold on, wait a minute. This was at 2 o'clock, right? So it's really the same as going an hour plus B later. Are you following me? Yeah. This is after 2, right? This is 3 and change. That's how I thought about, or how I can show you as quick as possible. The other way you can think about it is 2 o'clock is 120 minutes after noon. That's A minutes after 2 o'clock. This is 15 minutes after that, yes? Here's 3 o'clock, 180 minutes after noon. B minutes after. Do you see what happens? It simplifies to what I have, right? So however you want to think about it, it's up to you. We also know something. She says she is amused to note that A is 6 times B. What method would be best to solve this? Sub. A is 6B, right? So this is 6B plus 15 equals 60 plus B. This is a good move because now we have all B's. 5B equals 45, right? B is 9. So what time was it? 3:09 was when she looked at her watch the second time. 9 minutes after B. Or 9 minutes after 3. Do you have questions about that? I went kind of quick. Fantastic.
When did you retire Mountain Dew?
Since I ran out, and also since I'm sick, I'm trying to make sure I get plenty of hydration.
I know, but I feel like I haven't seen you drink Mountain Dew since I was in like 8th grade.
Oh, it's because you're not first hour. That's why. I drink my Mountain Dew in first hour. You can ask all my first hour kids. I drink one every day, right? I drink one every day, and I burp it constantly. Yes. Good. All right. Here's the reason for the season.
How many more is there of this?
One more, unless you want to do both versions of this. Okay. All right. We've got 3 different equations with 3 variables. Guys, the idea is we want to convert this to 2 equations with 2 variables. So how am I going to do that? Right? I'm going to pick 2 equations. I'm going to pick this one and this one first. And I'm going to add them to get rid of the y. Now, here's the trick. You have to get rid of the same variables both times. Okay? So I want to make 2 equations that have the same variables. In this case, I'm going to make two equations that have x and z in them, okay? I can in a second. I'm going to make two sets of equations that have x and z in them. So why did I pick the first and the third, do you think?
Because they have a positive zero and a negative.
Yeah, it's really easy to get rid of y and get x and z, right? So I'll do that over here. X plus 3y plus 2z equals 6. And I need the third equation, I said. Negative 2x minus 3y plus z equals 14. If I add them, this becomes negative x, this goes away, this becomes 3z, and this becomes 20. So my first equation is going to be negative x plus 3z equals 20. Okay? Do you see how that's one of my equations that now has only two variables? That's good. If I can find another equation with x and z in it, then this becomes a basic problem, right? And that's the idea. In fact, I'm so lazy that once you get it to here, you can just say you're done. Because I've already seen from earlier you know how to do that, right? Cool. Yes.
Can you pick any of those two? Like, you should
I-
the same answer.
Yes, I chose x and z because I saw y's are really easy to get rid of. Yeah, but it needs to be the same variable twice. If you have x and z here and this one's y and z, then you can't do anything with it, right? So now I'm going to pick equation 3 and equation 2. I'm going to pick these two this time. I'm going to pick these two because it's adding to get rid of the y value. But not yet, right?
You have to multiply by.
I have to multiply everything by 3. So here are the two that I'm going to work with. Equation 2 and equation 3. And after I times the top by 3, I get this. 29 times 3 is 60 plus 27, which is 87. And then this I'm not going to touch because I like that it has minus 3y. That's going to work really nicely. All right, am I going to add or subtract to make these go away? In this case, I'm going to add. That's why I chose these two instead of like these two, because they would have subtracted, and you guys are bad at subtracting. So if we add them, what do we get? Well, we're going to end up with negative 11x's. Is everybody cool with that? This goes away. We're going to end up with 16 z's. 80 and 10 makes 90, and that's 11. 101. 90 and 11 makes 101. I'd love to divide this, but nothing divides. So here are my two equations. Now, I know this looks nasty, but it's really not that bad. I'm going to finish it so you know how to do it. But if you were taking the test and you'd already proven that you know how to solve problems that look like this in the basics, you could be done, right? That's a great question. I'm going to take evidence from everything you've done all year. Some of you guys have zero evidence until you take the final because you've been that kind of kid. Shame on you. Others, you have tons of evidence. If I've seen you do this before correctly, then I have enough evidence probably that you could get it right from here. Okay? Is it subjective? Yes, but you're welcome that it's subjective. If it wasn't, it'd be a lot harder, right? Subjective means that it's made up. I make it up. Fun fact, did you know all grades are made up? Here's why. When a person that is a teacher decides that something is worth 5 points, could another teacher come by and be like, no, that's actually worth 6? They could, right? Everything is made up. When they make up the grade scale, homework's 15% in my class. Well, it's 10% in mine. It's all made up. It's all made up. So the question is, do you know your craft? That's what I really want to know.
So even if I set it up to there, but then I maybe got it wrong after, like even just because it was like the
Do you know how to do this concept is what I'm looking for, right? Yeah. That's why I'm giving you this. It's not so you can be perfect. It's so I can see if you know it, right? And you can know it without being perfect. All right, fam, I'm going to show you the rest of it, though, okay? Pretend we're here now and we want to actually solve it. Here's what I'm going to do. I am going to get x on its own on the top and plug it in here. So, black equation. X on its own is going to be 3z minus 20. Pause. Do you see how I got from here to here? Add x, subtract 20. Are you seeing it? I'm going to plug all of this into the blue equation for x. It'll be fine. It's not as bad as you think. I'm not going to make you do it on the test necessarily if you've already proven yourself earlier. Some of you have definitely not proven yourself earlier. But if that's the case, you're probably not doing this problem anyway. This becomes negative 33z's plus 220 plus 16z's equals 101. After we subtract that over and get these together, we get negative 15z's and this becomes 119. Did I do that right? I definitely did that wrong. This is negative 17. And it would be negative 119. Thank you. I'm going to make mistakes on accident today, guys. All right. 17 times what gets you 119? Do you know? 10's a bad answer. 6 is a bad answer because 6 times 7 ends in 2. It's 7. 7 times 10 is 70, and 7 times 7 is 49. Guess what 70 and 49 make? 119. So Z is 7. That's one of our answers. You might think, oh my God, it's going to take forever. No. That means this is 21, right? 21 minus 20 is? So X is 1. If X is 1 and Z is 7, that's 14 and 1 now, right? So that's 15. What do you take away from 14? Sorry. Yeah. What do you take away from 15 to get 6? 15 minus 9. How do I make this minus 9? Y is negative 3. There are 3 answers. Once you find the first one, the rest are easy. I'm done with this now. Do we want to do any of the advanced on 5? The advanced are kind of easy. You want to do them or no? For instance, I'm going to show you how easy some of these are. Do you see why this is true? Do you see why that is true? Well, they both equal 273, so don't they equal each other? If I subtract this, I get 1p. If I add that, I get 1q. What does that mean? P equals q, which means we can write the beginning equation like this. Instead of 92q, I can write 92p. And you can solve, can't you? Do you see how p and q are the same? So I switched out q for p. Why is that a good move? One variable. I get negative 79p. So guess what p is? P is negative 273 over 79. And guess what q is? The same thing. I win. That's an advanced question. The advanced ones aren't harder. They're actually oftentimes much shorter because you know what you're doing. But you have to actually know your crap. There's no way you can do it without. I'm not going to do any more unless you want to see them, though. We good? This isn't for you. Do your final, or I'm going to take it away. All right, moving on to 8. Is that what we said? I want to know what people want. 11 is on the final. It just doesn't hurt you. It can only help you. I know. And this is what happens when we do a giant review. What, is it okay if we go to 11?
You can go back, but I want to. We could always do 8 on Wednesday.
So 11 is what we want?
Yeah, well, that's when we video. For now. Yeah.
Yep. All right, we'll do 11. Do we want to start with the basics? No. I know.
Okay, can you do B of the basics?
Remember, this class is really hard. What?
Can you do B on 11?
Yeah. It changes. Sometimes it's doable, sometimes it isn't. This one is a perfect square. It's r plus 5. Do you see it?
Yes.
That's it. This one is not a perfect square because you'd have to do r plus 2, which would not get you a negative 4, or r minus 2, which it doesn't get you a negative 4 either, right? Is this a perfect square? If it was, it would be 20 and 20, right? But would 20 and 20 add to 20? No, not a perfect square.
Jesus. That was in my mouth, I think.
Sleep, Tiny. Sleep, Tiny. Thank you.
I have my quiz that I took earlier because I circled the ones that I needed. I won't write anything down. I promise.
I don't even know where it is. The one you took literally like 5 seconds ago?
5 seconds ago. So I can ask the question.
Tiny, wake up. Position 1.
No, stop. Don't do that. Riley, look at you writing your name all weird. Something happened to you today?
Yeah.
Why is she writing her name all curly-cued? Something happened to her? She fall in love? Uh-oh. I didn't know that. No, I did not. I don't pay attention to that crap. I should. All right. Does anybody want to see the first basics? Hey, I don't want to hear no's. I just want to hear yeses. Does anybody want to see the basics on 11? Yes? Let's just go page by page and I'll ask you.
Wait, 11, 4, 2.
Okay, so that's definitely a yes. Does anybody want these two? Difference of squares. Cubes.
Yes.
This is a difference of cubes. Isn't that x cubed? What number cubed is 1,000?
What number cube is it? 10?
Bye, Paula. See you later, maybe. Can you come another day, or is this your only day? Okay. Poor Paula. Hey, if you want to, circle the ones you want me to go over, and I'll make a video for you. Okay? Do that.
I know, and then I wasn't, and I can't.
Fam,
Problems I really want to do.
x times x squared is x cubed, right?
Yes.
Negative 10 times what gets you negative 1,000? Positive 100. Now we have some problems. Problem number 1. This and this gets us 100 x's. Do I want 100 x's? Do I want 100 x's? This has to get rid of it. Negative 10 times what gets us negative 100 x's? This is... Yeah, I got positive 100 x's. I need negative 100 x's. 10 gets me negative 100. Thank you. Notice it's these two put together.
You multiply A and B.
Yeah. It solves our other problem as well. Do you see how this is a problem? We get negative 10x squared. Well, this is going to get rid of it. Positive 10x squared.
It's just the symbols that get me messed up. I never know how to...
If you know what it means, the symbols won't screw you up.
I do know what...
I know, which is why you make it out most of the time. However, you keep missing like random negatives in spots. Stop.
But that will happen on the final because you have evidence and she knows.
Well, but most of the evidence so far has been wrong, so that's not good.
Are you kidding?
Yeah, you keep missing your negative signs. You're putting like random negatives all over the place. Fam, this is a sum of cubes. Okay, cool. So what number cubed is 27?
3.
And what do you cube to get r cubed? R. Good. And what number cubed is 64? 4. Yep, Landry's like, I know how to do this from Algebra 1. All right, cool. 3r times what gets you 27r cubed? 9r squared. Do you see how it's just this guy squared? See how this is just this guy squared? See how this is just this guy squared? 4 times what gets you 64? Positive 16. Thank you. Now, do you see how everything's positive? We have to have a negative somewhere to make things go away because we're going to get a bunch of stuff we don't want. For instance, we're going to end up with what am I talking about here? We're going to end up with 3 times 16r, and we don't want that. We don't want that. 3 times 16r. That is 30 plus 18, which is 48. So 48r, I don't want it. This has to get rid of it. What times 4 gets us negative 48r? Negative 12r. And you might notice, that's this. Yeah, but then you mess up all the negatives. Doesn't make any sense.
The positive to negative to negative to positive. Because I should not know.
I don't know, I just double check it out.
Yeah, that's what I would do. And then you spend 20 minutes like with the deradicalizing the denominator takes you 12 hours because you're just trying random combos, right? Yeah.
No, not anymore.
Not anymore. Not anymore. Yeah, not anymore. Yeah.
The first couple times I did.
Yeah, that's right. And hey, that's how you learn. You mess around with stuff. It's basically board work or what we did when we learned it, right? I get that. So we also have another problem. Our other problem is that this happens, and that gets us 36r squared. Does this fix that? 36r squared, negative 36r squared. We win. This is a what? A sum of what? Cubes. Sum of cubes.
Wait, what was the square formula?
Difference of squares?
Yeah.
Conjugates. Because no middle. the heck is wrong with you? All right. This is 3 cubed. Sorry, let me say it again. It's something squared. 3 cubed squared, yes? Oh, wait, hold on. We don't want squared. This isn't squared. See how the 9 isn't squared? I screwed up twice. This is something cubed plus something cubed. All right, 3 to the what cubed? 3 squared, thank you.
Turn your camera back on so it's recording. Yeah.
This is not recording me. It's this thing.
Then why was that on? Come on, Riley, lock it. I thought you were talking.
Because it just turns on when I turn my computer on. And then I forget to turn it off and it overheats. So thank you for reminding me it was on. And when I have a real mic that does the room, I'll walk around. But I can't.
Oh, my God. Did you raise Monica? I do not like this girl.
Fam,
I know, but
fam, what are we cubing to get 2 to the 9th?
2/3.
Yep, so it's 9 cubed plus 8 cubed. That's what we're doing here. Do you know how to factor cubes? Yes, you do. Okay, that's fine. This is 9 plus 8 times 9 squared plus 8 squared minus 9 times 8. Are you following my logic?
Okay, hold on. I don't understand how we went. Oh, okay. Never mind.
It's the difference of cubes formula, or sum of cubes formula.
No, it was just how we got from 3 squared cubed to 9 cubed, and then I got it.
Yep, so this shows us what we're cubing, right?
Yeah.
And then that's what goes here. So what we're going to do is 9 plus 8, which is 17. And then we're going to do all of this, which is going to be 81 plus 64, which is 145, minus 72, which is 73. Hey, look. Whatever this god-awful number is, it factors to 17 times 73. Grimace. Thank you. Purple. Bye-bye. He's tired of your crap. He told me.
So then if it's squared, it's just conjugate? You know what I mean?
Yeah. Difference of squared is conjugates. You need the middle to go away, and you need a minus sign, so it's got to be one of each sign. All right, fam, would you like to see 1141? I need a yes for 1141.
Yes. Just be them.
Okay, so I'm going to write it over here nice and big. Yes, nice and big. Stop making it weird.
What's her name?
Rasputia? What?
From Norbit. No, that was just the first thing that came to my head.
That's crazy. I was thinking race, but that's kind of weird.
I like Chris.
Otherwise we'll get in trouble if we do that.
Yes. All right, friends. Why did I multiply this by the 5th root of 9 to the 4th over the 5th root of 9 to the 4th? What is the 5th root of 9 to the 4th over the 5th root of 9 to the 4th? Yes. Doesn't change anything. Why did I choose 5th root of 9 to the 4th? That's right. The 5th root of 9 to the 5th is what I get, and that just becomes 9. These multiply, and I get 2 times the 5th root of 9 to the 4th. And I'm just going to leave it like that, because all we care about is the bottom.
I have a question.
Yes.
Okay, so like when we are doing like the ones where there's like 3 in the bottom, like, do you really care about the top?
No.
Like if I just do like
Gracie, we're getting mad. That's the whole reason.
Yeah, but I don't care about the top. Ignore it.
okay, just making sure.
I trust.
Because I don't think I
Yep.
What I don't understand is how 9 root 5 times 9 to the 4th root 5
Don't worry,
makes 9 to the 5th root 5. I don't understand.
Ignore the roots, because the roots don't really matter. What's 9 times 9 to the 4th? Good. And then it's all 5th rooted. Yeah, you can multiply roots. Yeah. We're in advanced stuff here, so. Well, actually, I mean, we kind of are.
Why would I just multiply by that?
I need page it's
Just let him ask it and open statement.
Macy wanted 11.42, so we're doing 11.42.
She's not here. She is not.
But she can hear you right now.
Well, you're not supposed to say our names, so now you're gonna get fired. Right.
Who said I was talking about Macy? I was talking about Camden when I said Macy.
yeah, that's what I was talking about.
Now no one will know Macy's name.
That's my name, Justin.
Whoops. We need conjugates, right?
Yeah.
When we do this, the reason we're getting conjugates is because 1 times 1 is 1. This becomes negative root 5. This is positive root 5. Do you see how they go away? Okay, stop. This is the bottom. 1 times 1 is 1. What's 1 times negative root 5? And this is positive root 5. That's why we need conjugates, so that goes away. And what's root 5 times negative root 5? Negative root 25. That's the bottom. 2 times everything is just 2 minus 2 root 5. Now, what is the root of 25?
5.
So we get 2 minus 2 root 5 all over 1 minus 5. What is 1 minus 5? Negative 4. And we do need to simplify. Everything divides out by 2. This becomes 1 minus root 5 all over negative 2. Yes.
Okay, so if you're doing 2 and you're distributing it always distributes to both things. So if it was like 3 times root 3, it would be 9 times 3 root 3.
It distributes to every term. What makes something a separate term?
The plus or minus.
Yep, so if there's no plus or minus, it just hits it once.
And then if you're dividing it, yeah, it can go to both. Okay. I kept getting confused. I didn't know if it went to both or just one.
But now you know it's terms, right?
Yeah.
All right, I'm going to do this one because I think Macy wanted to see this one. And by Macy, I meant Camden or something. I don't remember. Right? None of your names are online now. It's fine. Everybody messes up on this one because they don't know how to multiply correctly.
Because I always never do the 2.
Yes. I get to know you guys really well from these quizzes, which is why I love doing them. I know you guys hate them, but that's life. Hello. All right, the top I'm going to do first. What's root 7 times 3? 3 root 7. What's root 7 times 2 root 7? 2 root 49, right? Which simplifies, but I'll come back to that later. We cool with that? Hey, the bottom is going to be 9. Then these are going to go away, right? And I'm going to get negative 4 root 49. Aren't I, Briley? Who?
All the way home.
It's like 5 feet.
I said it would be nice if you
You
would
did
write it.
3 times that, which is 9, and then you did 3 times 2.
Goes away. 6 root 7 minus 6 root 7 goes away.
Not anymore. You got less.
So you just skip it.
It goes away. Yeah. And then this becomes negative 4 root 49. You didn't do root 7, root 7. You wrote root 7 here. Maybe it wasn't you. Maybe it was somebody else.
Can you divide the thing?
All right. Do we see how I got it? This is 4 times 7, isn't it?
I was trying to divide the 2.
You were, yeah. But you can't because you need to do it to every single term. And when there's multiple terms on the bottom, never divide like that. That was the one thing you didn't get from me in Algebra 1, and I regret it. Thank you. I'm trying. You got other things, though. I'm very proud of you. Talking to Briley. I said, you got other things, though, and I'm very proud of you. You make me very happy. What?
1131.
Grace is stuck in it too. I don't want to do it.
No, I literally just did it, Cameron.
You did it wrong.
What? No, I didn't.
We're on the basics. They're on the intermediates. Does anybody want to see either of these?
We did these in class.
Because we know them now and we're not going to do the hardest way possible to do them.
Yes, I know. Did it.
Why do you guys do everything the longest possible way? I don't understand. Like, if you just use your brain, it's really fast. Okay. Instead, you're like, I'm going to follow the steps. All right. Do you want to see this one, 11-1-2? No yeses? Okay. 11-1-3. It is if you know it. All I want to hear is yes. Do you want to know it? Okay, cool. This is b times b. That's the area of this, so that's b squared. The area of this rectangle is AB, isn't it? The area of this rectangle is AB. And the area of this square is a squared. This is a plus b times a plus b, isn't it? Are you seeing it? And if we add up all of these, don't we get this? It proves that they're the same. Geometrically. All right, computing these in our heads. Some of you guys are not doing this the right way. You're trying to, oh, they left, but that's okay. 40 minus 9 would work, or you could think 30 plus 1 times 30 plus 1. Yeah, that's the strat. So we get 30 times 30, which is 900. We get 30 twice, which is 60, and then we get 1. So 961. Minus 1 times 300 minus 1. Yeah, that's fine. Yeah, I don't care. That's fine. But if you're doing it by, like, carrying ones and stuff, no, absolutely not. And most of the time, I don't even have to wonder if I count it, because when you do that, you guys screw it up. Because it's harder. 30, and it's literally the same thing as this. It's just harder. 30 times, or 300 times 300 is 9 with 1, 2, 3, 4 zeros. This is minus 600 now, because I got 2 of those. Add 1, because it's negative 1 times negative 1. So that's going to be 89,401. No, you can grab it yourself. They're up there. Also, I'm going to scan this and send it to you. So watch the show and think. I don't know. You can't use notes on the thing anyway. You probably feel better, but does it actually help you if you don't look at it later? I'm asking. Then don't worry about it.
11 on the final does.
Mercer Mumford? Wait, what?
You knew I was dating Mercer Mumford.
I did not know that. That's crazy. That's crazy. That's crazy. Mercer Mumford. Okay. Oh my God.
Mr. Mackey says that you like him.
I do like Mercer, but I don't. But for absolute reference, there is not a single boy in the school that any of you should be dating. They all suck. No offense. Okay. That's how it goes. They all suck. Camden's all right. Camden's all right. Camden's all right. But in general, yeah, there you go. But in general, stop. Okay, go somewhere else where the gene pool's a little bit wider. Okay, that's my advice for everybody. Okay, for all you know, he could be your uncle. Okay, all right. So anyway, here we go. Yeah, well. All right. So, do we want to see these two or no? I need a yes. Anybody? Yes. Yes. Okay. This is a difference of squares. Camden, what do difference of squares factor to? I mean, these are binomials, but they're conjugates because they're opposite signs, right?
I don't know what you're asking.
I know. He wanted to skip it. Do you see how this gets rid of the middle that we would get? Do you see how it gets us negative c squared? Thank God. All right, here, you might think to yourself, this isn't possible because 800 isn't a square number, and you would be correct. It is not a square number, but you would be wrong. It is not impossible. What common factor do they both share? Let's factor first. They both share 8, don't they? What else do they share? X. Hooray. question your judgment. All right, 8x squared. 10x. You could have not taken out the x's. It would have worked as well, but, like, this will be the best. Minus 3y, and then 10x plus 3y. Yikes. All right, 1122, yes or no?
Yes.
Nope, just I want to hear yeses. So yes, okay, cool. So we're going to use this fact to our advantage to figure this out.
Shut up, I already did it. You did it, and then you did it.
Yeah, Briley, I'm going to take that quiz back from you very soon. You figured out my secret.
What?
Nothing. Maybe you didn't.
Writing with a purple pen, bro.
What does that matter?
How would I be changing my answer?
I didn't say you were changing your answers. You're saying you're changing your answers.
You just said you found out my secret.
This is true. You found out my secret. All right. You see how this is true? Right? Now, why is this good? This sounds awful, right? It's good because we know this. So when we do this, we don't have to actually calculate it in our head. We can just use what they gave us. 308, 635, 8024, or 25, I mean. Now, here's something fun. Aren't we going to get this twice? Yes, it is unfortunate. So we're going to get 50,000 and 50,000. Doesn't that make 100,000? And then 5,000 and 5,000 makes 10,000. 500 and 500 makes another 1,000. Oh, wait, what? What did I goof up here? This is 50 and 50, which is 100. Okay, my bad. I put the comma in the wrong spot. I'm really bad at commas, guys. Then I get 50 and 50, which is 100. I get 5 and 5, which is 10. Right? And don't forget, we also get 1 times 1.
So there's 3.
So there are a total of 6 ones. So 1, 2, 3, 4, 5, 6 are all going to increase by 1.
Oh my. Okay, can I just wait? No.
I'm way faster at this than you are, aren't I?
I got this. Okay, I need the next.
Yes. Let me look. Let me look. I don't remember off the top of my head.
I'm putting this on top of Landry Mumford.
Yeah, it's fine. Yeah, yeah, it's fine. This is all being recorded.
Mr. Mac, where's this being recorded at?
YouTube.
I looked online. I looked up Derek McNally.
No, it's
and I
not.
found
No, it's not a real math teacher.
Why did I know? I looked up both of your accounts and it was like last updated 6 years ago. I'm like, how am I supposed to know?
Mr. Mac, the like photo image of you is you like looking at your rabbit.
I know. End it all, yes.
Is that a zero?
He told us in 8th grade that he does that on his
No, I make Riley sign my name on some paper. She has fancy handwriting.
If Cameron makes me the demo paper, so I forwarded this thing.
That's great.
We already did something like this, so we don't have to do it again.
Yeah, sorry. I just remembered something awful. All right. What, no. What is the... Do we want to do this or no? Can I hear a yes?
I did.
Yes? Okay. They are perfect squares. It is 3 to the 4th squared. And this is 2 cubed squared, isn't it? So in other words, this is 81 squared. And this is 8 squared. So they are square numbers, right? That means that this means this. So that means this. So how do we factor this? Camden, how do we factor this?
81 minus 8
Thank you. Minus plus, but yes. That means this will come out to 73, and this will come out to 89. You'll get 89 and 73.
Not how I did it anyway.
Reverse.
I did it way harder.
Yo, you didn't do your cute Grace laugh. What the heck?
Also, I'm
Hi.
so confused. I did 11.5.
You hate Cheetos. You hate Fritos. Like Rice Krispies?
Fritos will work.
Like I said, Abigail's sick, so it's been a while. Well, I appreciate you being cool. Thanks for taking care of me. Thank you. Thank you.
I did that one the same way I did it every
No.
single homework, and I got it wrong every
Fam, factor as much as possible. All right, let's just use our brains. What will we need? Oops, sorry. Yes? Hey, look, Camden, what are these? Is this factorable? This is not factorable. If you use 2 and 2, you'll get middles, won't you? Is this factorable? Because we can use 2 and negative 2 and we won't get middles. Because they're what, Camden? Because they're what, Camden? Thank you. That's as much as you can do. This is not factorable.
So hold on, where do we get
Just
the
playing it smooth.
W minus 2 and the W plus? Where do you think?
Stop.
That's why I got it wrong in the thing, because it wasn't factored.
This is a difference of squares, exactly.
Right.
So you can factor it to conjugates. Is this a difference of squares? There is no such thing as a sum of squares. Because you'll get middles if you have 2 and 2, right?
If it was 81 would work, right? Or sorry, 27. No. Oh gosh, I'm blanking on what.
You're thinking if it was cubes. Then yeah, you could do a sum of cubes. Yeah, you could, but that's not cube. It's a square.
So 81.
No, you would need W cubed plus 27 or something.
Okay, yeah, that's what I meant.
Yeah, then it would be cubes and you could factor it. Yeah. 4? We got this worked out. Okay. Remedial English and I, we go way back. We go way back. Yeah. Okay. All right. Here's the story. I'm doing the play, and this kid's after cleaning up with us. I'm like, "What are you here for?" He's like, "I just really like literature, and so that's why I'm here." I said, "Which one's literature?" And I pointed at all the ladies. He's like, "That one." Pointed at her. So she's literature, and he's remedial English. Yeah. That's because he's younger than her. Thank you. I thought it was cute. Remember what I said earlier about all the boys in the school? I stand by it. I stand by it. Some are better than others, but I stand by it. All right, 11-3-1, yes or no? What is this? Difference of cubes. If you really wanted to, you could do this. And then you could factor that. Oops, sorry. That works, right? Do you see how this is 1 cubed? Do you see how this is 2z cubed? That gets you back to this, and then you need this in the middle. Thank you very much. Appreciate you. What can we factor out of both of these? Do you see it? That'll be easier to work with. This is not a difference, is it? It's a sum. So I'll write that down here. That's going to factor negative AB plus 2. And then we're going to get A squared B squared plus 4. And on the middle, we're going to get minus 2AB. Yes. Do you see how we need AB? Because that's what it is, right? AB cubed, 2 cubed. Right. So then we need the squares here, the squares there, and then we need them there. Cool. Much easier if you factor out the negative, isn't it, Grace? I really, really, really don't want to do this one.
That's the whole reason I'm here. Please. That's actually the whole reason I'm here. That one and the one below it. Because those are the only ones I don't have my
Mac already told me how to do it. I don't know why he's not listening.
You want to tell us how to do it?
Yeah, I'll tell you how to do it. Ready? So it's gonna be
Here, hold on. How do I wake this thing up? I forget how to wake it up.
Mr. Mac, can you do the rest of these, like the rest of that page and on the back, so that I can look at the video? Thank you. Bye.
Grace, where are you
I'm gonna do it
No,
here.
I'm just going up there because I gotta do it. And then I'm gotta go to, because I gotta go to the gym apparently. I didn't even know that. I don't listen, I don't think.
You don't have a game to like 7.
I know. Want me to do it on the board?
Yes.
I got you.
So hold on, let me make sure you're on screen.
Don't worry, I'll do it. Oh, no, I haven't found one. What's the rest of it?
You need plus the cube root of 9. Here, and I'll write it. That's the difference.
Alright, so you're just gonna copy what I did? Alright. So it has to be like this.
Period, Grace falling though.
Yeah, period, because
Your little defense.
this is it squared, and then this is them multiplied, and this is squared again, because you need to do it. Okay. And then you're gonna
I'm not sure
distribute.
if that's right.
So I'm gonna distribute. It might be positive.
Do you have a final answer?
Yeah.
That you're like, no, this one.
Not that. I'm not checking it yet. I'll believe it when I see it.
I'm doing it. I'm not.
I know, that's why it's gonna save me time, because I don't have to do it. And I appreciate that, because my brain is not good today.
Oh no.
Negative
See,
3,
you're
that's
admitting it's super
cube
hard.
root of 3 squared. That doesn't go away.
How is not advanced?
Because advanced doesn't mean hard, right? And medium doesn't mean easy. It's just the first thing you need to learn, and this is the second version of it, right? Look at the end.
Why roots?
This is the same thing.
It probably is.
So those go away. These two. Boom, boom. And then this one.
What happened? Okay, never mind.
Where am I at? I'm gonna write it down. So then this will just equal 3. And then
Doesn't 9 have a nice?
Nope, it has like square root.
oh my gosh. Wait, it might be to the second.
It is.
Yeah.
Grace, you wrote to the
This has to
second.
be
on my-
second.
Oh my gosh, I literally wrote that on
It
Cameron's
says B2.
paper.
Do it.
On
Do it.
campaign.
Do it.
Gosh,
Alright.
dang it, Grace.
I win.
I lit have it on.
I'm gonna beat her. I'm gonna do it.
No, 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 I wasn't ready.
Wait, hold on. I goofed that. Crap.
Yeah, good. Oh no.
This is negative 3
Oh god, I don't know what I'm doing.
cube root of 3 cubed.
Oh my god.
Why would you tell us how to do it if you didn't know how?
I know how to do it. I'm not stupid.
Yeah, and how'd you figure that out?
Shut up, I'm not stupid.
How'd you figure that out, Grace?
Plus
I just did.
3. What?
Grace is
81.
AI.
That doesn't come out nicely. And that's gonna be minus 3 cube root of 9.
What the? I did this on my home. Wait,
That doesn't mean it's
Grace
right.
Monica, what are you doing?
no, I lit did it. This is how you do it.
You lit and did not do it. And you lit didn't do it right.
These don't go away.
Back here.
These don't go away. And talking about?
So you see the orange?
Yeah.
Can't you combine those to make it negative 27?
No, we're not timesing, we're adding, and these aren't the same roots.
Shoot, I did that on my homework.
I know you
did
did.
it wrong.
You need a,
Why isn't that right though? Can you tell me?
that's a great question. But it's much harder to be like, here's why you did doesn't work. That could literally be anything,
What's
right?
your way?
Yeah, what's your?
Do you have the equation?
Why is it
My
right?
thought is this. Okay?
Alright, well, I gotta skedaddle.
Alright, we'll skedaddle.
Sorry, you two.
I'm sorry, I gotta
It's
go.
all your fault.
No.
I love you, Grace Monaco. See, I love Grace Monaco.
Why'd you switch that to your negative?
Because that's the form this is in.
Oh,
Like,
So this should have been a positive. First.
oh, that's what you meant by flipping them?
Yeah, well, it's, do you see this? This is gonna get us a cube.
It's the cube thing.
We need cubes to get rid of cube roots. Yeah. And so, am I visible 100% on here? I am, right? Okay, good. All right, at least this is. Okay, so that's what we want. So what is A? Is A the cube root of 3? Well, then this would be the square of the cube root of 3. I think it's reversed, like these two are flipped. Hey, Cam. I think these are flipped in the original. So I'm gonna write it like this. It's the same thing though, you see that?
Yeah, yeah.
Right? So this gets us back, so this is, if we square this, we should get this, right? Yep, works out. If we square this, we should get this. Yep, works out. If we times these together, A and B, we should get this. Yep, works out. Are you seeing it? Yes. All right, I'll let Ken take it.
Minus of x minus this thing from 7y minus a negative 4y. What happens when you minus a negative 4y?
So b equals 3. So b equals 3, and then a will be root 3, 3.
All right, so here's the idea. See other cube roots?
Yes, it is. Yeah.
No, I know, Liz, right? So we want cube roots to go away. So what do we need to do? We need to multiply by something that looks like this because this gets us this. Do you see how it like cubes the stuff individually? So we need to multiply by this. This is the difference of cubes or sum of cubes factorization. Do you see how this fits the pattern, right? This is a squared. Here's a. This squared. Are you seeing it?
Yeah.
Okay, a squared. Do you see how b is 3?
Yeah.
Because this is b squared.
But then what do you do after that?
And then if these are AB, we need this, right? So what do you do after that? You distribute them.
You have to distribute.
Distribute and you distribute. Yeah. Now here's the deal. You know the shortcut. It's going to turn into this when you distribute.
Oh, wait,
You're going to get A cubed. Well, you're going to get this cubed. So you're going to get 3 cubed, cube rooted. You're going to get B cubed, which is 27, right? So guess what you get? You get 3 plus 27. What is that? 30. So the bottom is now 30. And the top, since you're doing the same thing to the top and the bottom, is going to be 4 cube root of 3 plus 12. You win. Oh, and we can simplify that. 2 cube root of 3 plus 6 all over 15.
Yeah, I got it.
Yeah, I know. I'm going to leave it up there for you. Okay, so that's the big brain play. I think the 4 is missing over here. Let me move the camera a little bit. That is not an easy problem. It's intermediate, but it's harder than intermediate, what you guys think. Because intermediate doesn't mean it's medium level difficulty. It means it's the step 2 of what you've already learned. Sometimes step 2 is tough, because step 1 was tough, right? So if you don't know that one, that's okay. It's okay. You'll be all right. Kentucky. You want to learn it? You can start weeks ago. What? I'm not talking. What? Oh, yeah, this one? Yeah, it's 4. All right, cool. So that's that on that. While Cam continues to digest, I'm going to go back here because it's going to take a while to get through all of these guys that are going off. The sound isn't working, so at least we're not being bombarded by that. I know, right? All right, this next one's much easier because it's roots. So here's what we're going to do. Here's the big brain idea. If this were the problem, wouldn't we multiply by conjugates and we win? Okay, here's what I'm thinking. Treat this like it's one number. So what's the conjugate going to be? It's going to be minus root 7, and then whatever this number is, right? Okay. See how I didn't change this part, but I changed that? That's super really important. We got to do it over each other. Cam keeps doing this where he changes like all the signs, and so does Reed, and it doesn't work for them, and they get mad. But that's the idea. This plus root 7, well, the conjugate would be this minus root 7. That's it. Now I just got to distribute, okay? So let's do that. Root 2 times root 2 is the root of 4. Root 2 times negative root 5 is negative root 10. Root 2 times negative root 7 is negative root 14. Now we got to do root negative 5 times everything. That's root negative 10. That's going to get us positive root 25. That's good. And that's going to get us positive root 35. After distributing the root 7, we get positive root 14. That's good. That'll go away with that. This is negative root 35, and then this will come out to negative root 49. So notice everything's going to go away here or become a nice number except for one of our roots. This becomes 2. This becomes 5. And this becomes minus 7. What's 2 and 5 minus 7?
0.
Yeah.
Wait, I had this right.
What is negative root 14 and positive root 14? 0. What about root 35 and negative root 35? That's 0. Now, the one catch is that this did not go away. I've got 2 negative root 10s, right? So that's going to be negative 2 root 10. You might think, oh, crap, I screwed this up. That's what gets a lot of people. But you didn't. Okay, so the top is 2 times all this. So it's 2 root 2 minus 2 root 5 minus 2 root 7. You didn't screw it up. Because you know how to solve a problem like Maria. All you have to do is times by root 10 top and bottom, and you win. We don't even need to conjugate, because root 10 times root 10 will go away, and we win. So let's do that. Sometimes you'll need the conjugate if there was a number here, but our number went away, the 2, 5, and the 7. Okay. So what we're going to end up with is negative 2 times 10, which is negative 20. And in the top, we're going to get 2 root 20 minus 2 root 50 minus 2 root 70. And now we win. I'll zoom out. How do we feel about that last one? Cam to cam, are we digesting that really hard cube root thing? Yes. Okay, cool. All right, I'm going to pause, and I will be back. I can't keep doing it. Okay. Yeah, this one is diamond because it's in the so you gotta go to the section. Well, you've been doing the ones that are, you've already got this. So.
Okay, I do understand.
Yeah. This is going to be tough to learn all at the last minute, but it will be possible to review it and learn a little bit at the last minute, and that is our goal. Good news, I'm recording this. Good news, we're not done. Good news, your final isn't for 3 more days. You're going to be okay. And JV practice got canceled, right? There you go. We're going to be fine. But yeah, I don't recommend learning 16 weeks worth of stuff in 3 hours. Don't recommend that. But it can be reviewed in 3 hours. It can probably be learned in 6, honestly. You need experience. You don't have enough experience because you didn't do the homework and stuff, at least not until late. But that's okay. We're not here to discuss that. What we're here to say is that we're going to make this work. All right. I don't want to do this one. I hate it. It's easy. You just do it and whatever. Who cares? The problem is that the way to do it from left to right without any knowledge is actually easier than what they're trying to get you to see. So we're going to skip it. Do we want to do 11.5.4? Yes or no? 11.5.4 is tough. 11 is like the hardest quiz we take when it comes to the middle, like the intermediate questions. It definitely is. It definitely is. And it's largely because Algebra 1, you guys noped out on Section 8 and 7, where you're like, I don't need roots. Roots aren't real. This is BS, Mr. Mac. I'm not doing roots. And then here we are. Turns out everything's roots and squares and stuff. So I heard nothing on 11.5.4. Is that true, Lyric? Would you like to see 11.5.4? Okay. So here's the idea. We want to write this number as a fraction plus another fraction. Okay? And here are the rules. N cannot equal m because it has to be distinct. Here are the other rules. N and m have to be positive integers. So that means they got to be whole numbers, right? Or natural numbers, right? 0 doesn't count. And that makes sense because you can't divide by 0. So this is the question. What are all the fractions that have 1 on top that add to 6? 1/6. That's the question. So how are we going to solve this? Well, this is a tough question because fractions, right? How do we get rid of fractions? Yeah, well, you could get commutanomics, but we can multiply because it's an equation. So let's times everything by 6, n, and m. Now, why am I timesing by all of that? Yeah, it's going to get rid of some of the stuff, right? This first one, the n's divide out. And we get 6m times 1, which will be 6m. Here, the m's divide out, and we get 6n times 1, which is 6n. Here, the 6's divide out, and we get mn times 1. And mn times 1 is mn, or nm, whatever. This is going to be factorable. Check this out. If I rewrite it as mn minus 6m minus 6n equals 0, we have a quadratic equation. Thank you. Yeah, that's what they all say. All right, later. So, what would I factor this to? I would factor it to m times n, right? And what would I need here and here? Nope. If I put a positive 3 here, I'm going to get 3m. Do I want 3m? So a minus 6. What do I put here? Another minus 6. Now here's the problem. What we wrote is not equal to what this is. Check it. This gets us mn, love it. This gets us negative 6m, love it. This gets us negative 6n, love it. But it doesn't get us 36. So here's what we're going to do to fix that. Now it works, doesn't it? But I have to add 36 to both sides. So the question becomes this. What times what gets you 36? And we're going to find all the possible ways you can do it. Okay? So I'm going to get a separate sheet of paper, and I'm going to show, actually I'll do it on the board, even though we'll have to wait for the thing to pop back. Okay. So here's what we're going to do. Here's all this. All right. So we have this question. M minus 6 times n minus 6 gets us positive 36. Now, the catch is this, don't forget, m and n have to be positive integers, right? And they are not the same. So let's think of all the ways we can multiply to 36. Let's be organized here. 1 and 36 works, right? What about 36 and 1? So what I'm saying is we're going to plug a number in here, and it's going to get us these guys. Does that make sense? Okay, cool. And then we'll. So 2 and 18 works. So does 18 and 2. Right, because it wouldn't be distinct. We would need like 12 and 12 for both, and that would make sense. So 2 works, 3 works. That's 3 and 12, 12 and 3. Oops. 12 and 3, let me get out of the way. 12 and 3. We can also do 4 and 9, and 9 and 4. And then the next one would be what did I miss? 6 and 6. So we know we're done, right? We're not going to do 6 and 6, and here's why. Do you see that? Well, we're going to do it, but we're not going to do it twice. Because do you see if I flipped it, it doesn't make a difference, right? And then the other catch is, if they both have to be 6, wouldn't m and n both be 12? That's not distinct. It's true that 1/12 plus 1/12 does get you 1/6, right? But we wanted distinct, right? So that one we're not going to count, okay? Now, what about negatives? What if we did negative 1 and negative 36? In order to make this negative, and this is where Cam got me a little lost earlier, and if I was more awake, I would have said, Negative 1. What would m have to be?
Negative.
Try again.
Sorry, 7.
No.
It'd be 5.
5.
5.
That works. M is positive. M is 5. Now here's the catch. What would n have to be to get negative 36? Negative 28. So it's
Oh,
out.
then I know it's. Okay.
Right, so that's not going to work. Well, we need to check all these to be sure. Negative 2 and negative 18. N would have to be negative, right? So that's not going to work. Negative 3 and negative 12. N would have to be negative 6. So that's not going to work. Negative 4 and negative 9. N would have to be negative 3. So that's not going to work. And then we have negative 6 and negative 6.
So it's negative.
M and N would be 0. But is 0 positive?
No.
No. So yeah, we don't need to account for the negatives. There are occasions where you will. But in this case, it's not what they're interested in. So now we need to make a chart about what M and N actually are. So let's do that. So if this is 1, M is 7. Is everybody following me on that? And if this is 36, N is 42, right? Right? Does that make sense?
Right.
So 1/7 plus 1/42 is equal to 1/6. That's kind of crazy, huh? It's true. If this is 36, we get this. Now, what do you notice? Are they distinct? 1/7 plus 1/42 is the same thing as 1/42 plus 1/47. We don't need these. We don't need these. We can cross all these off. They're not going to be distinct. Right? We're going to get the same numbers. You can't tell them apart. Okay? So that's totally fine. All right. So then we need 2 and 18. So that's going to get us, oh, I'll erase this. So 2 and 18. What does M have to be if we want it to be 2 overall? 8. And what does N have to be if we want it to be 18? Yep. If we want 4 and 9, we're going to need 10 and 15. Are you following me? And that's all of them. Here are our 3 possible answers.
Wait, hold on.
I will.
Did you skip 3 and 12?
3 would need 9, and yeah, we did. 9 and 18. My bad.
9 and 18, you said?
Yeah, because 9 minus 6 gets you 3, and 18 minus 6 gets you 12. So there are 4 answers. 1, 2, 3, there. 4. So let's find the unit fractions. So our unit fractions, and I'll come back to here now. No, I mean, you'll see anything for like 10 seconds. Our unit fractions would be 1 over 7 plus 1 over 42. That gets you a sixth. We would get 1 over 8 plus 1 over 24. That adds to a sixth. 1/10 plus 1/15 adds to a sixth. And apparently 1/9 plus 1/18 also adds to a sixth. That's all the ways to make a sixth without repeating any fractions and having 1 on top. It's kind of wild, right? All right, 1155. Briley wanted to see it, I'm pretty sure. So we're going to do it. Guess what? This is the same problem we just had, except it's easier. This factors, kind of. What would this factor to?
3
plus 5 and 2 9
I always did it.
Yes. And then, does this actually factor? No.
No.
Because this has minus 15 and this doesn't. So we got to give it minus 15. And now we have something that actually is factored correctly, right? This is going to be a huge part of where we're going, where we're going to be able to factor anything by just putting on some extra numbers. And that'll make the problem doable. Okay, so now we need to find all the pairs of integers. What are integers?
Numbers.
What kind of numbers?
Whole numbers and then negatives.
And they're negatives, yeah. And, yep, that was perfect. That was perfect. So how many ways are there to multiply to negative 15? Well, we could do negative 1 and positive 15. We could do positive 1 and negative 15. Those are integers, right? We could do 15 here and negative 1 there. Negative 15 here and positive 1 there. There's a lot. We could do 3 and negative 5. We could do negative 3 and positive 5. We could do 5 and negative 3. We could do 5 and positive 3. And there you go. So now we need to find numbers for P and Q that work. Let's do that here.
I have 5.
So 5 and 3. Oh, you have that one already?
The original thing.
I don't know what that means.
If you plug 5 in for P in the original equation.
Oh, it works, yeah. And 3 for Q. Yeah, that's true. So what numbers do P and Q have to be to make negative 1 and 15? Well, P has to be negative 6.
Where's number?
And this has to be 18. Ember hasn't been here all day. Well, hasn't been here since after school. If this is 1, I need P to be negative 4, and I need this to be negative 12. You with me on that? Negative 4 plus 5 is 1. Negative 12 minus 3 is 15, negative 15. P is 10. Q is 2. Here I would need P to be negative 20, and Q would have to be 2. Wait, did I goof that? Yeah, that'd be 4, because I want it to be positive 1. Here, P would have to be negative 2 to get us 3. And here, Q would have to be negative 2 as well to get us negative 5. To get negative 3, we'd have to do negative 8. To make this equal 5, we would have to do 8, yep, positive 8. To make this equal 5, we do 0. And to make this equal negative 3, we do 0. So 0 and 0 is another answer, right? That makes sense. And to make this 5, oh wait, hold on. I need one of these to be negative. So this one is going to be negative 10. And this one's going to be positive 6. So there are all our possible answers. Yeah.
Can you check this one problem?
What number is it?
It's on a different one.
Great. Wonderful. I'll pause. We're basically at the end, so I got to go quick. Which one, this or this?
This
Okay, so A would be 3, B would be cube root of 2. Yeah. Okay, you wrote that. And then that means you're timesing it by what? You didn't show your work? No, you didn't show your work? How am I supposed to check this? 3 times is 27. That'll be 2. And then middle should go away, right? So you're going to get 27 and you're going to get 2, which is 29. Right?
and that simplifies out.
Yeah. All right. That's page 7. We're on the spicies. Does anyone want to see chapter 11 spicy?
I don't understand how your numbers getting so big. Do you multiply by the A plus B scale?
No, that's going to get rid of all your crap, right? So really, what does it end up being? It just ends up giving you A cubed plus B cubed if you did it right.
Yeah.
So what's A cubed?
9.
What's B cubed?
2.
Stop. What is A? So 3 cubed is not 9. 27. Thank you.
Yeah, that's the whole reason as well.
There you go. All right. Yeah, I didn't know at first, but that makes sense. You did 9 plus 2 instead of 27 plus 2 or whatever. All right. So no spicies. Lyrics like, I'm kind of game, but okay. Well, what if I do them later or something? Because we only have 10 minutes or 5 minutes left. Do you guys want to talk about any other quiz yet?
I need to go over 8 and come back for
Okay. All right.
I'll tell you, I can come back.
You're
I'll
welcome.
Back and read it.
Yep, no problem. All right, we're going to close this down. I'm going to start uploading it before the internet dies. And then we're going to move on to the algebra review. Woo! And we got Chloe in house. Love Chloe. Chloe's the best. Chloe is wonderful.